For lesson 22, let's take another step with fractions. Let's talk about dividing fractions. First, one thing you should remember is that you never divide a fraction. You always flip the second fraction and change the operation to multiplication. Then you just follow the steps for multiplying fractions. Remember, you can always reduce individual fractions. That's before you flip them or after you flip them. You can always cross-reduce once they have been flipped. You cannot cross-reduce division. You can only cross-reduce fractions that are being multiplied. So don't make the mistake of cross-reducing early, but you can't always reduce an individual fraction itself. Let's take a look at example 1, which says 2/93 divided by 5/6. First, we're going to change it to multiplication by saying 2/93. In other words, the first fraction has to stay the same. It cannot change. We change the operation to multiplication, and we invert or flip the second fraction. Now, let's see if anything can be reduced. I'm talking cross-reducing is probably our best bet here. I don't see anything that can individually be reduced. 2 and 5 won't work, 2 and 93 won't work, but 93 and 6 have a common factor, and it's the factor 3. Now, how do I know that 93 will divide by 3? Well, 3 is one of those numbers that you can check by adding the digits, like 9 plus 3 is equal to 12. 12 is divisible by 3, therefore 93 is also divisible by 3. Don't try this with 4s, it only works with 3s, okay? But that's something you can do to check and see if a number is divisible by 3. 93 is, and 6 is, so let's divide them both by 3. 6 divided by 3 is 2. 93 divided by 3 would be 31. It looks like our lowest form, so let's start multiplying. Numerator times numerator, 2 times 2 is 4. And denominator times denominator, here I've got 31 times 5. Well, you probably have to write that down. I usually do too, but I'm going to say 5 times 1 is 5, and then 5 times 3 is 15. I can sort of do that in my head. The answer, 4 over 155. Example 2. One of these numbers is a negative, but that's okay. We know with division, an odd number of negatives gives us a negative answer, so I'm just going to write it down and circle it. My answer will be negative, and I'll check that when I finish. Let's see if I can change this into a multiplication problem by saying negative 6 over 15 times 5 over 12. Now it looks like I can cross-reduce some of these things. 5 will go into both 5 and 15, and 6 will divide into both 6 and 12. Now I just have to multiply numerators times numerator, remembering the negative that I'm multiplying, and denominator times denominator. My answer, negative 1/6. I said my answer would be negative, and it is. Example 3 looks like a negative divided by negative. That's going to be a positive answer, so I'm going to put it down and circle it so that I don't mess that up. I'm going to change these by saying negative 4/15 times negative 3/8. I flipped the second fraction and changed it to multiplication. And then I can reduce. I can cross-reduce because nothing individually reduces. 3 and 15 will both divide into those numbers. 3 will divide into both 3 and 15. And 4 is going to divide into both 4 and 8. So when I multiply negative 1 times negative 1, positive 1. 5 times 2, 10. My answer, 1/10. It is positive, so I checked the signs and it's working right. Number 4, 9z over 20 divided by 2/9 is the same as times 9 over 2. Now, here's where it really messes us up sometimes. When you looked at that division problem, you probably thought, oh wow, it cross-reduces really well. Remember, you cannot cross-reduce division. It has to be in multiplication form. So we can't cross-reduce this at all. Nothing is going to reduce or cross-reduce. We're stuck with just multiplying numerator times numerator. 9 times 9z is 81z. And denominator times denominator, 20 times 2 is 40, and that's our lowest form. Second, number 5 has division by a whole number. Let's turn it into a fraction by writing 4 over 1. Now, let's change this into negative 2/3 times 1 over 4. Well, I should have looked in the beginning and said, okay, I've only got one negative in this problem, so I'm going to have a negative answer. I can reduce here, cross-reduce the 2's. 2 will go into 2 and 4. And now I'm going to multiply 1 times 1, 3 times 2, negative 1/6. When you have a fraction with a negative, it doesn't matter if the negative is in the numerator, out front, or in the denominator. What it means is that the entire fraction is negative. Normally, we either put it out front or in the numerator. You rarely see one in the denominator. Example 6, another whole number. Let's put it over the number 1 so that we can make sense of it. Now let's write it as a multiplication of the reciprocal, which is the flipped fraction. 5 over 3c squared. Okay, I want to do some reducing here. And it does look like it's going to be a little hard. But I see 3 and 15. Let's go ahead and do that. 5 and 1. Now, what about c cubed and c squared? Think about it. C cubed is c times c, and c squared is c times c. Well, two of those c's are going to cancel, aren't they? Sort of like subtracting the exponents. I'll have nothing down here in the denominator, but I had c times c times c. I'll cancel out two of them in the numerator. All that's left is just 1c. So now I can multiply. Numerators, 5c times 5 is 25c. Denominators, 1 times 1 is 1. And when you have a 1 in a denominator, you really have a whole number. We don't ever write 1 in the denominator. We just write that as 25c. Example 7. What am I going to be doing? First, I've got to work what's inside parentheses, don't I? Order of operations still counts here. So I know I'm going to just leave this problem alone until I can figure out what to do with this. So I want to say negative 4 35ths divided by, and let's just work these two fractions inside the parentheses. I would say 4 times 3 would give me 12, and 5 times 7 would give me 35. Now, at least I'm just dealing with one fraction. Times a negative, looks like I'm going to have a negative answer. A negative times a positive. So, let's change this again. It's going to be negative 4 35ths times 35 twelfths. Well, that made things nice and easy. The 35s, of course, would cancel and reduce and just be 1 over 1. 4 will divide into both 4 and 12. Don't forget my negative out here. Negative 1 times 1 is negative 1. The denominator, 1 times 3, is 3. The answer, I said it would be negative. It is. It's negative 1/3.